Okay, good afternoon. As I told you, I was not going to be here today. We are going to try to work in OpenRocket. I have a Canvas assignment which has this data for your rocket parts. We've already started and done the first two, the body and the nose cone, and we were working on the fins a little bit. Um, so now we're going to start working number three, the inside tube, center rings, locks, engine, the rest of the stuff on the list here. I'm going to try to walk through it with you, and we're going to try to go fairly fast. We're going to open up OpenRocket, so you need to make sure you go and get one of my laptops and open up OpenRocket. If it doesn't have OpenRocket on that laptop, grab a different one. The top row should all have uh, OpenRocket installed on them. So we're going to go File, and I'm going to go Open. Yours would be in the very last file on here, which should be your name, the Z drive with your name on it. Mine is in downloads, and we're going to do trial one because that's what we left off with in class. So we have our nose cone, we have our body tube, and we have our fins, which you were working on when we last left off. Okay, so now we're going to try to put the engine mount in there. So inside tube, it says the Estes BT20, and that I cut them to about 5 centimeters. So I'm going to go over here and choose this body tube because I got to say, where is it going? And I'm going to say the inner tube. So I choose the inner tube, and then I'm looking for the Estes, ESTES, and I'm looking for the BT20. I have one here that I found that is 1.5 inches, and we're just going to have to change that dimension. I'm going to hit close because I've chosen it. I'm going to come up here, and the length I'm going to say is 5 centimeters, and that changes the length to 5 centimeters. Okay, there's one more piece we need to do on this, and we're going to go to motor because this piece is going to have a motor in it. So I'm going to click here. We're going to have an overhang, but we'll worry about that here in just a second. This motor overhang, we're going to talk about that in just a second. So I'm going to say okay, and there's my engine mount. We're going to try the center rings now. I'm still on the inner tube, and I'm going to come here to center ring, and I'm going to click on it. And if we look at the data, it says that the center ring is an Estes AR 2050. So I'm going to come back over here, and I'm going to say Estes, and I'm looking for the AR 2050. And so it goes from a BT20 to a BT50, which is what those two tubes are. So I'm going to say close because there it is. And it's all the way at the end. For yours, everything here is correct. We would have this positive relevance from the bottom of the parent component. So on yours, if yours is not lined up directly at the edge there, um, you may need to either move this piece down, or we're going to move this piece in. And if I say plus, and if I say, let's say it's 0.5 centimeters, oh no, that took it out of the bottom. We don't want that. It would be negative 0.5 centimeters, and that'll move it up on the inside. You'll see it's on the inside here. And again, that's where you start looking at which way does it fit in here. I'm going to say okay. And this time, instead of going and grabbing the same thing, I'm going to 2-finger click on this and say duplicate. And there it is, duplicated. Now it's right on top of it, so it doesn't really look like anything's happened. Double tap, and then on this one, I want it to be right at 5. And so it's -5 because +5 would put it below. Oh, +5 is on top of it. So maybe I'm going to say 4.5. Oops, 4.5. That's not quite enough. So what happens if I say 4.7? Nope. 4.25. Yeah, there we go. And if you remember yours to be further back or further forward, that's your choice. Maybe it really is only 4 centimeters from the bottom. You have to make yours. Okay, trying to remember what yours was. Try to be as accurate as you can. All right, so now we need the engine block. That's the little bitty tiny ring. The engine block is an Estes EB20A. So come over here. I'm going to click back on the inner tube and I'm going to use the engine block. And once again, it's Estes, ESTES, and it's an EB20A. EB20A, and I'm going to hit close. Now it's all the way down here at the bottom. So what does that mean? We need to change this to 5 centimeters because it's 5 centimeters up. Oh, not positive, negative 5 centimeters. And that doesn't work either. So we need to change it to 4.25. Let's see what we got there. Oh, negative 4.25. Enter. That's pretty close. Maybe it's 4.3 because it was right there at the end. And I'm getting really close now. So again, you're trying to be as accurate as you possibly can. I'm going to leave all of the rest of this stuff as it is. I'm going to say okay, and there's my engine mount. Now to put the engine in. If you look at the instructions, it says that the engine is an Estes B6 with a 4-second delay. But the Estes B6. Okay, so I'm going to go back to the inner tube. And this time, instead of doing the rocket design, I'm going to come over here to motors and configuration. So I click on that. The inner tube is already chosen. If I click on the body tube, it'll choose that one also. We don't want that one. So we're just on the body tube. I click off, nothing happens. Okay, then we're going to do a new configuration. Now, there's all kinds of engines here, and sometimes it's hard to figure out which one's which, especially when we start doing other engines. So I'm going to go change this total impulse to B. I'm going to change this one from O down to B. And now we have only the B engines, and we're looking for the Estes B6. It has a total impulse of 4. It happens to be 4. And then our ejection charge delay is 4 seconds. So we have to change this to 4, and then I'm going to say okay. And now you'll notice that the engine is too far up inside. So I'm going to come over here back to engine rocket design, go back to the inner tube, double tap, and now here's that, motor, and now here's that motor overhang. And you need to look at yours. Where does it overhang? How much does it overhang? Is it 2 centimeters? For mine, looking here, the engine lock is still in the way. So maybe I'm going to say 2.75. And that's pretty close to what mine really is. All right, but you need to figure out yours. See if you can figure out what that measurement needs to be. Put it inside your rocket and measure it. That's the easy way to do it. Then we'll say, okay, all right. Now we've done, so I go back to my list. What have we done? We've done the body tube, nose cone, inside tube, center rings, engine block, engine, fins. Now we need the streamer. So I'm coming back to the streamer. It says that we're looking for something that is 1 inch by 24 inches. Well, the streamer is going to be attached to the nose cone. So I'm going to click on the nose cone, and I don't see a streamer here. Oh, wait a minute. If I scroll down a little bit, now we have a streamer. So there's our streamer, and there's all these thousands of streamers here. We're looking for one that has 1 inch by 24 inches. So I'm looking here. These are all 4 inches. Here's 1 inch by 24 inches. There it is. This is an SP124, which is what I said in the instructions. So there's the length of it. And then I'm going to say close. And you'll notice it's all the way up here at the tip. Well, once again, we need to set that positive relevance, or that position relevance, sorry. And I'm going to say 10 centimeters because it needs to go below the nose cone. So it's measuring from the top of the parent component. So it's measuring from the tip top here, and it's going back 10 centimeters. Everything else on here is fine. It's made of polyethylene, which is fine. I'm going to say okay. And then the last piece we need to do is the launch lug. And the launch lug is, you need to measure yours because they've all been cut weird, different sizes. Measure your launch lug and make sure it lines up with where yours is for real. So I'm going to come over here. I'm going to say the body tube because, again, that's where it's going to be. And then I'm looking, there it is, launch lug. Choose the launch lug. And this is going to be, and again, I want it's not balsa, it's made of paper, it's 1/8 inch diameter. So I'm just going to use this first Estes one here. It's 1/8 inch diameter. This one says it's 1.25 inches long. We know that that's not right because I'm going to go have to choose it, but I'm choosing the first Estes because it's made of paper. So here we go. I'm going to hit close. There it is. And now I need to mess with it. Mine is 5 centimeters long, so it's a little bit longer. And that position relevance, now this says from the middle. I don't want to try to guess what the middle is. I'm going to guess from the top of the rocket. So it's going from the top of the rocket to this, and it says 20. I know mine's not 20. I measured it, and it came out to be uh, uh, 15. And I'm making this up, but you need to actually measure yours. And so I'm going to say 15 centimeters, and there it is. Now, the last piece, and I'm not going to show you how to do this. Over here, the stability. It says my stability is 2.38, which is too much. My center of gravity is above my center of pressure. That's because of my fins. I changed my fin size. If I go in and change my fin size, trying to make it look like it really is, um, and the shape here, and I start changing it, you'll notice the stability changes on yours as you change the fin size. You want to make sure that the distance, that the red one is at the bottom, the blue one is at the top, and the distance between them is 1.5 or as close to 1.5 as you can get. To do that, we need to nose cone, and I'm going to add a mass component because I know that I need to add weight. For yours, we know we need to add weight to the front. So I'm going to click here on my mass component, and then how many grams does it need to be? So that's what you've got to figure out. Where's yours? What does it look like? What does that fin look like? If I go back and change the fin to something that is normal, if I get rid of my fin from this freeform thing, delete, and I put in the fin body tube, and I put in a fin that is normal fin. For mine, I said that it has 4 fins, and the dimensions. So that fin can't. How many degrees? What is yours? That's not it. Oh, that's the cant for making it spin. The chord is the length of the fin. The root chord is the bottom length. Tip chord. So if I made mine 8 and the tip chord is 0, and the height from the bottom to the top is 4. And again, what does yours look like? So now I have all these things. Where is your center of gravity? And how much weight do you need to add? Where does that weight need to go? If I have this mass in the nose here, or do I need that mass to be much closer to the middle of the rocket? If I change this to 10 and put it right where the parachute is, my stability is 1.72. If I change it to 20 and put it right in the middle of the rocket, nothing changes. If I put it towards the engine of the rocket, what is happening to your stability. For me, not much, because I've made some mistakes here. You need to figure out where does yours line up best. That's your job for the day. You need to figure that out. Take a picture, screenshot of this information, and turn it into me on Canvas before the end of class. Good luck. And if I can come by, I will. If not, we'll see you on Friday.